Hello everybody, this is Jose. On this episode we are going to take a look at what is machine learning, what is AI, and also what is the machine learning workflow. And everything we're going to take a look today is applicable to any tool, any tooling where we can do machine learning. It's pretty general, but also it's fundamental. So we understand later on we can talk about what is Azure machine learning. So let's get started. And if you like what you see, please hit like down below and subscribe. Hey, we're going to take a look at what is machine learning. Even what we are going to see now is related to Azure machine learning. It's pretty general, so it works with any framework, any way of doing machine learning, and also it is essential. These concepts we are going to take a look now. What is AI? What is machine learning? Deep learning? How does machine learning work? What kind of machine learning algorithm do we have? And what is the machine learning workflow? They are pretty important because this is what we are going to learn how to do that afterwards with Azure machine learning. And also it's kind of necessary to learn these concepts before jumping into Azure machine learning. So without further ado, let's get started. AI refresh. Essentially, what is AI? AI is the ability of machines, computers, any kind of device that we can have from IoT, from phones to tablets, to mimic human behavior. This started in 1950, because as soon as we could program software, then we tried to mimic intelligence, right? At least from intelligent beings. Some humans have our intelligence, Then, afterwards, 1980, it came machine learning, which is the ability of machines to make predictions based on its experience, which for machines is data. This has been quite successful. It's based on mostly statistical and mathematical formulas, which we call some machine learning algorithms. Oops, I have complex with this word. And basically, a lot of AI is based on statistics or mathematics, computerized. And then we have deep learning, which is where it starts to shine, because essentially it mimics the human brain. How do we, as humans, process information, take decisions, analyze things? And it's mimicking our human brain structure. Essentially, how do we lay out different groups and sections of neural networks, which are artificial, and essentially they mimic our neurons. This started in 2010 with a lot of success. Essentially, this is what is enabling now the latest advances. It's deep learning what makes these I believe the AlphaGo was already deep learning, if I'm not wrong, and enabled to beat the world champion in Go game using kind of machine learning algorithm. And also the way these new robots you have seen everywhere, they are jumping, dancing, doing everything. It's because they are trained using the same algorithm, or kind of algorithm. And as well as latest advances in human language in understanding and generation, GPT-3. If you are familiar with AI or you have searched YouTube or the web for it, GPT-3 is what is empowering code generation, text generation at a level which is pretty similar to human, and also enables taking or analyzing text from computers in a very natural way and essentially the same level of a human. That's it. Let's see how does a machine learning work. We have some data, it's labeled, we train a model, we deploy the model once trained, it can see a picture and say it's a Bellis perennis. Let's see it again. We have a lot of data, we label it, we train a model, and the model later on can see an image, a picture, and classify it properly. Machine learning algorithms, like the one we saw, fall into three main categories: supervised, unsupervised, and reinforcement. Supervised is exactly one of that we have seen, which is classification. It relies on humans labeling the data, essentially. So it can work for text, it can work for images, as you saw, like determining, is that a dog, is that a cat, or that would be a binary classification, or a multi-class if we have a lot of different flowers, like we saw just a moment ago. Then we have unsupervised, which usually relies on what we call clustering. We do nothing and the computer algorithm then decides what to do, essentially. So it tries to cluster and group together similar kinds of pieces of data, or simply put away pieces of data that don't fit. That would be a nice way to determine a fraud which is not detectable with the usual supervised algorithm. Then we have reinforcement learning. This is the one I mentioned that enabled in AlphaGo to win the world champion. This is the one that is used to train, for example, Spot, the dog robot, or to walk or to run or to jump or to dance, right? Reinforcement, supported by other techniques, is you have a set of rules that determine a set of scoreboard, and which determines how good was regarding its outcome, a concrete move or action that the computer or the algorithm took in a game or a robot, the step it took, if it was good or not, right? And then we can train the model to make better decisions at every single step. And if we do that in a simulated environment, like millions and millions of times, then we end up with a model that can beat the world champion easily. That's what was used as well to beat the, I think it was the champion of some games, like, what was the name of the game? Yeah, DeepMind. I think it was used to beat us or a professional team in StarCraft 2 in a restricted environment. Apart from that, it's also used to do nice things like learn from us to generate language and code, or determine amino acid sequences, or these kind of things. Pretty cool. Then we have the machine learning workflow as well. The machine learning workflow is the process of training a machine learning model, which has several steps. Usually we divide that into two. We have a training phase, which is the first part, and then the prediction phase. One is to generate and train a model. For that, we have to first select a model that fits the problem we are trying to solve. Then we have supervised, reinforcement, or unsupervised. We will see different kind of models later on, but at the moment, put that we have the data, we have some pictures of flowers, so we have to extract them from online libraries or do the pictures in our own or in an automated way, which could take some time. Then we have to transform the data to a concrete resolution, to a concrete format, which is ready for the algorithm to consume. And then we have to label it as well properly and revise it, and then to load that to train the model. Then we have to train the model, and the ways of training may generate different models. And then we select the model, the best one, and we deploy it. Once it's deployed, the prediction or inferencing phase takes in action, and it can receive unknown data or similar data and provide a prediction, which may be accurate or not, depends on the quality of the model. And then afterwards, we could, after a while, refeed more data to the model and retrain it to make it better. And that's basically what we have seen is essentially the different concepts on AI, machine learning, deep learning, and the kind of workflow that we will be implementing in short with Azure Machine Learning. See you on the next episode. And again, if you like what you see, click down below, unsubscribe, and give it a like. See you next time.